Good evening. Am I audible?
Hi, this is Pratap.
Yeah, Pratap. Just give me 1 or 2 minutes, huh?
Okay.
Yeah. Okay, so before people are joining, uh, let us try to have some introduction about each and everyone. So Pratap, I will start with you. So at high level, can we have your high level introduction?
Yeah, Sri, hey, this is Pratap.
Okay.
I'm working as an Oracle database administrator since
Uh-huh.
2011.
Okay.
So I would like to learn the latest technologies. And when it comes to the Oracle, I did plenty of migrations, database upgrades,
So
and uh, migrations from physical data center to AWS.
agree.
So like that, I have good experience.
Okay.
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 So now I'm planning to learn the new technology, Snowflake.
So you want to migrate to Snowflake DBA, correct? No?
Yeah, yeah.
Okay.
So that's my expectations.
I got it. I got it. That's okay. That's totally okay. And how about can see user? I know who is that? Who joined with name user?
Hello, Srinivas.
Yes.
This is Madhavi. I've been trying to reach you since there was no response. I just
Right.
joined this meeting hoping to connect with you.
We'll connect after the call. Okay.
Please do call me back,
Yeah. Yeah.
Srinivas.
Yeah. Yeah.
Okay, thank
Yeah.
you.
Hey Sunil. Hi Sunil. Sunil.
Yeah, hi Sri. Good evening.
Yeah. Yeah. Because I just about to start. So we are getting
Okay,
some high level introduction about everyone.
okay.
So just at high level, your background and your motivation for this training.
Yeah, my name is Sunil. I have over 13 years experience in IT,
Mm-hmm.
and my skills are database administration skill like Oracle, Postgres, SQL Server, and I'm learning for this for the to upgrade my career.
Okay.
So looking on Snowflake database area. So that's it.
Okay. Okay. That's fine.
So Sri, this only dedicated to admin and database admin stuff
Correct.
only.
Correct. Correct. Correct.
Okay, fine. Thank you.
We have two more people joined. Just give me a minute. Okay. So just to start with today's demo, right? So just to give a heads about myself. So my name is Srinivas and I have nearly 20 plus years of IT experience, and I come up with a combination of data engineering and then data science. And I'm currently working as a Snowflake cloud architect in a multinational UK bank. And my role is basically to manage the entire Snowflake environment and also build the data pipelines on top of that. So I do work on the database management and also the database development both, because as per my project requirement, and I majorly deal with AWS cloud, and where my database integrations and data pipeline integrations are happening with AWS cloud with Snowflake. And coming to like other technologies, I am also familiar with Python and some part of data science which I worked on. So all these are like I use on a daily basis, and to manage my Snowflake data DB activities also I automate using Python. Most of the like uh, automations I do with Snowpark and Python, and I also built my own interface in Python and Snowpark to make my life easier to automate some of the database activities and migrations, all this stuff. So now today, let me try to give a high-level overview on, you might have already worked on some database administration, maybe in other databases, but how Snowflake is going to differentiate, that we'll see. Let me share my screen.
So as being a Oracle DBA, so how soon he can catch up to this, Snowflake admin? So things will be
Almost same only, because most of the activities which you might have done already in Oracle as a DBA, here also you have to do, but you need to know the method which you need to follow, like what are the different activities which you can perform at the Snowflake environment specific, you have to know. For example,
okay.
every DBA in any database will have some common activities.
Correct.
Apart
Yeah.
from that, Snowflake specifically, you may need to go and learn. So if I say organization, so that is only specific to Snowflake. It may not be available in Oracle or other databases. So Snowflake organization is nothing but one object which you need to create before creating any Snowflake account. So you need to know what is Snowflake organization, how to manage it organization level, and also account level. I'll discuss about that, okay?
Sure. Yeah. Okay.
Well, let me share my screen. And here, just to understand, is everybody familiar with Snowflake already, or anybody new to Snowflake here?
No, we are very new to Snowflake.
Okay, how about others? Pratap, Prabraj, and
Yeah, I'm also new to Snowflake.
okay.
Yeah, no,
Okay, that's fine. So Snowflake, right? So there are so many databases in the market, and why Snowflake? So Snowflake is a software as a service, which is like a SaaS product, which is hosted on a cloud environment. Like for example, if you go to any databases in the market like Oracle or SQL Server, and these particular databases can be installed in on-premise, and also nowadays they are coming with cloud. But Snowflake can only use on the cloud environment. You need to go and create a Snowflake account, and you need to log in into that particular Snowflake interface, and you need to run your command, because Snowflake can be executed only on the Snowflake hosted environment, and there is no hardware is required to install, and there is no software required to install, and even maintenance also is not our responsibility. So all the patching, upgrading, maintenance will be taken care by Snowflake team. We just need to create an account, log in, and start using it. Because Snowflake come up with a cloud environment, and this cloud can be either it can be AWS, or it can be Azure, or it can be Google Cloud, based on the cloud you select while creating the account. So Snowflake, while creating the account, it will give you an option which cloud you want to host your Snowflake account. So you need to select either AWS or Azure or GCP. These three clouds Snowflake is offering now, and you need to select according to the cloud which your company is using. For example, your company is already using AWS. If you select create and create an Azure, that is not going to help you. So you need to select the right cloud provider also. I'll show you how to create a Snowflake account also. But what you have to understand here is Snowflake is a cloud environment and cloud database, which is a single unique platform for maintaining data warehouses. Also, I can create a data lake, and I can also implement data science and machine learning and generative applications also on top of the data which we store in the Snowflake environment. And Snowflake come up with many different features. And why people are choosing Snowflake is also, there are so many reasons. If you come and see in the traditional on-premise database, there are so many challenges in on-premise traditional data warehouse if you go and see. Why? Because every traditional data warehouse will be having the performance perspective. As a DBA, you might have seen how to go and tune your environment on the slow performing queries, and sometimes your concurrent issues also you'll experience, and the latency you will see, and you also will see the maintenance side also some complexity. Definitely you have to manually go and to a database level and application and query level you have to do. During the upgrades also you would have seen some challenges. And the scaling issues also you might have seen. So every on-premise databases and the traditional data architecture is having some limitations and challenges, but all these will be eliminated by using Snowflake. For example, Snowflake come up with a unified data cloud and with near zero maintenance, because no tuning is required, and then no need to manage any service because Snowflake team will take care of that, and automated scaling. So scaling also will be automatically done by Snowflake whenever required, and pay as you go. So pay and use and pay. You do not need to pay anything upfront. And also it will decouple or separate the compute and storage. When you go and see in Oracle or SQL Server, you will combine, right? You will combine both the storage and compute. When you want to upgrade your storage, or you want to upgrade your like server capacity or compute, you need to stop the database server, and the downtime is expected. But here in Snowflake, you do not need to worry, because Snowflake will come up with a environment where the compute and storage are separated. So when I want to increase my storage, I can increase whenever I want. When I want to increase my compute, I can increase anytime. Even my queries are getting executed. So Snowflake will use a feature called virtual warehouses, where this virtual warehouse is the fundamental backbone for running your SQL statements. All the resources like CPU, temporary storage, memory, all will be provided by the virtual warehouse to run your SQL statements. So when you are running your SQL statements, you need to have a virtual warehouse running in a started state. And this virtual warehouse also will come up like a with different sizes, like our t-shirt size, X small, small, medium. So when the warehouse size increased, automatically the performance also will increase. At the same time, the cost also will increase. So when the warehouse size increase means your resources will be more, and your SQL statements or queries will run faster, and you will experience high efficiency and fast execution of your queries. At the same time, you need to pay. Snowflake will charge the customer in different ways. The Snowflake pricing is also one of the very important area which, as a Snowflake DBA, we need to focus more, because if you don't have any control, as you know already, as a DBA, that you should have a control over the environment and the cost perspective and performance perspective both. So Snowflake will charge the customer in different ways. A compute cost. When you are running any SQL query, you will need to pay, because Snowflake will provide the resources. When you are storing any data, you have to pay. Snowflake will charge the storage cost only if you store. When you are transferring any data from one region to another region, you need to pay data transfer cost, but only when you transfer. That too, they will charge per terabyte. Either it's the storage cost or data transfer cost, you need to pay per terabyte, but the compute cost will be calculated according to Snowflake fundamental unit called credits. Each credit will be per minute they will charge, and per second. If your query is running for 10 minutes, and you will, based on the warehouse size, the number of credits also will be increased. Number of credits means that is equal to your money. If it's a X small warehouse you are using, you need to pay 1 credit per hour. So 1 credit means you will have some charges, like $2.3, for example, which is a small size. And even the cost also will have some factors according to the region you are using, according to the cloud you are using, according to the warehouse size you are using, and according to the Snowflake edition you are using. These charges will be different. All these information as a DBA you should have clarity, because a Snowflake DBA is very responsible for cost optimization also. And also, if you go and see, Snowflake for traditional databases will follow a shared nothing architecture, as you know, where the compute and storage are combined. But in case of Snowflake, Snowflake will come up with shared disk and then shared nothing architecture, a combination of hybrid. A shared disk is nothing but the data will be shared across the nodes. And shared nothing is the compute is not shared. The compute is independent with the warehouses. Every warehouse is independent. Every warehouse is a group of clusters, and each cluster is a group of nodes. So the virtual warehouses are very, very important. And these virtual warehouses can be instantly, we can automatically will be auto scaled by Snowflake. And unlimited concurrent users can use the virtual warehouse to run their queries. A Snowflake will automatically increase the number of clusters whenever needed, and they will provide the resources to run the queries. For that, they will charge us. That will be charged on the cloud services cost. And the data will be available in the single location and will be accessible to all, because it follows a multi-cluster shared data architecture. Scale up and scale out, I'll discuss about that. But most of the traditional data warehouses will have challenges at on-premise. So Snowflake is one of the solution in the cloud database environment, where you will see the data will be in a shared location. At the same time, you also experience the compute also will be decoupled, so that concurrent users can use the compute and they can leverage to run the queries. And coming to like why Snowflake is very, very popular in the market. The Snowflake is very simple. You can use simple and serverless and plug and play. So I can simply create a Snowflake account within 1 minute and I can start using it. It is not like how you maintain a database environment, how you want to install Oracle database or SQL Server database, and you need some sequence of steps to follow, where you download and install and configure the properties. You do many things. But Snowflake environment is very easy to create and start using it. And scalability, so I can scale up to any amount of data, any number of users, and any amount of workload. There is no restriction from Snowflake side. And elasticity, the instant elasticity, increasing the size. As I mentioned, Snowflake is providing the concept of virtual warehouses for compute. So this virtual warehouses size, I can increase anytime, small to medium, medium to large, or I can even bring back to from medium to small also. Even my queries are running, I can change it. But in the traditional databases, we cannot, right? Yes or no? Can we bring like the storage down or increase the storage when the queries are running? No, right?
No option.
You cannot, because you need to stop the database server. Then only we can do. But here in Snowflake, we can do that. And flexible cost, there is no any upfront expenses. Pay for only what you are using. Snowflake will not charge the customer for anything extra. all the data will be located in one single location and can be accessed by multiple users of that environment. Even when you are running any query, Snowflake provides the compute will not be charged every time. For the first time only, they will try to use the credits. The second time onwards, your query results will be stored in query cache, and that will be reused every time up to 24 hours, so that your credits will not be consumed. So you will have a zero cost. So only one time you have to execute. The second time onwards, your warehouse will be utilized and your credits will not be consumed at all. The caching will try to help you. And apart from that, Snowflake is mainly cost effective and accessible, and then multi-cluster shared data architecture, and compare it to like other cloud database like Amazon Redshift, we have like Teradata, Google BigQuery, Oracle Cloud. All these are also available, but they have their own challenges, because if you go and see in those databases, storage and compute are coupled. And Snowflake come up with many different features for saving the cost and flexibility and accessibility. And pricing side also, you will have very, very transparent pricing where you can go and receive the monthly billing, and you can also monitor the cost in the Snowflake environment by using the admin tab. As an administrator, we will have a control, and where you can go and even see different ways to control. So mainly the infinite scalability, and it is providing the unlimited storage capacity, that too like in the cloud environment. And Snowflake also will use a normal ANSI scale only, standard scale. And it will come with different other features. So where I want to go and share my data to any other users, what is the process usually will follow in any project to share the data with other team members in general? Anyone?
Other data means?
No, how you are going to share the data with others? Any data, for example, I have some data in a table, and I want to share with other teams who are not part of that environment. You will download that data, right, and store in a file, and then
basically we can take the backup and we can share with them.
Correct. But physically you are going to share, correct? No.
Yeah.
But physically, when you share, some customers may not be interested, right? Sensitive data.
Yeah, of course. Yeah. They cannot trust us basically.
Correct.
Because, yeah, some level of security approvals also required.
Correct. So Snowflake have a feature called secure data sharing, where I can share the data without physically transferring also.
Oh, is it?
Yeah. If you have a Snowflake account, I have a Snowflake account, I can use the feature called secure data sharing. So I can share my group of tables with you, and where you can only see the data. You can't change anything also, just like read only.
Okay.
So that is called secure data sharing. And sometimes you may need to apply some kind of masking also. So why we apply masking? So I want to control the access to unauthorized people, correct? No, social SSN number, for example, SSN or email, I want to hide or mask it. So Snowflake come up with a feature called dynamic data masking. It is not going to physically change anything. The column value data will be masked only when you select that column dynamically. So to achieve that, I need to use a masking policy. And one more interesting thing with Snowflake is I can create one masking policy for a particular email column, and I can apply to thousands of email columns. One masking policy.
So in one table?
Assume that I have so many email columns in so many different tables. So, but the masking policy will be same, right? Normally, I want to hide only email, and I want to display the domain.
Yeah.
So I can get one single masking policy, and that masking policy can be applied to any email column in any table in any database.
Okay.
So that is called dynamic data masking. That is column level masking. And also I can do row level masking also. For example, I want to control country level data. Only I want to authorize people to see only their country data. So I can use row level masking. So data masking is another feature. And we also have features which Snowflake is providing, other features like supporting different data types also, like I can use JSON data, I can use parquet data, XML data, Avro, ORC, CSV. So all these kinds of file formats I can use in Snowflake, I can load into the Snowflake environment. But I don't know, usually in Oracle and all, it is not easy, right? To load this semi-structured data and all, that much easy comparatively.
Yeah, that much easy. Yeah, that is a little bit complications, but the
But
futures.
here, but we can do that, but it's complicated.
Yeah, we can do that.
But in Snowflake, we can directly dump the data into a variant column.
Okay.
From the variant column, I can extract. So we do not need to do any transformation before loading. I can apply my transformations after I load it into a generic variant column, and from there I can extract what data I want.
Okay.
And one more interesting thing, like assume that I got a scenario where I dropped a table. And as a DBA, you will have a control. Assume that. And you have a backup and you can restore it. But provided if you don't have a backup, you can't restore, right? Normally. In general. There are scenarios where there is sensitive data, maybe 1 month back that got deleted. And I want to restore it. But I need to do so much work. I need to go in deeper and I need to do some like my workarounds. I need to restore the data. Correct or not?
Yeah, there are some new enhancement came into the
Correct. I
picture.
agree. But in general, the complexity, see, I'm talking about complexity.
Yeah, that complexity is also reduced. Okay, as the new features are coming into the Oracle.
I totally agree. But coming to my experience, I'm saying about, see,
okay, yeah, maybe,
but the new features maybe, but in Snowflake, it is very easy with the time travel.
Okay. Oh, got it. Okay.
So time travel is a feature where I can go back to a particular point of time and I can restore, maybe 1 week back.
Okay.
Or 2 weeks back. I can go up to 90 days.
Okay.
I can restore the data. Assume that I'm not sure about what data I deleted. I want to restore the entire table. So assume I have dropped a table. I want to restore at the entire table level. We have a undropped table name also. Even the table is dropped, I can restore by using drop table name. I dropped a table. There is an undropped table name which will restore the table back immediately. And one more interesting feature is zero copy cloning. So cloning, you might have seen the term cloning. So when you want to create any backup environments from production, like development and testing and QA, whatever it is, you will have an additional storage cost, correct? No?
Yep.
But in Snowflake, if I use cloning, your storage cost will be 0. Snowflake will not going to charge any storage cost for any cloned databases or cloned tables or cloned schemas. So that will help you to save your storage cost also.
So is it for only cloned databases, right?
Correct.
Not for the new database. Okay.
No, if you physically create copy, then you will be charged.
Okay.
But when you clone a database from the production database, assume I have a production database and I cloned 2 databases from that, maybe 1 terabyte. So 1 terabyte will be only charged for production. For the cloned databases, the cost will be 0. So there will be no cost will be charged for any cloned objects. It can be database or schema or table, whatever it is.
But it's going to be occupy some storage, right? Even cloned databases?
No. Only if there are any changes, it will create a separate micropartition. If there are no any changes, all the databases will share the same micropartition.
Okay, so that means they will access the data from the production itself, right?
Correct. The micropartitions will be shared between the databases. But the changes will be independent. If you do any changes to clone database, that will not be reflected in production. And whatever the changes you perform in the production also will not be reflected in the clone databases.
Okay.
Only for the changes, it will create again a new micropartition. A micropartition here means a file, a group of records. So all these like will be automatically done by Snowflake in the background, but we need to know how to manage that.
Okay.
And coming to like other features, like we have admin side also, we have some roles and responsibilities every like administrator will do, but fundamentally the data in Snowflake will be automatically compressed. Snowflake will, whatever data you store in Snowflake will be automatically compressed by Snowflake, and each table, whatever you go and load the data, will be divided into a group of micro partitions. So logically, it will be like we can select like a row, but internally, physically, it will store like a one micro partition. And each micro partition will have a range of 50 to 500 MB. And that particular micro partition also will store in the column format. And which is basically maintained by Snowflake itself. Snowflake will use its own intelligent algorithm to divide the data into a group of micro partitions. And whenever required, it will try to select the data from the micro partitions and it will provide the data to us. And as I mentioned, virtual warehouses are very key for Snowflake environment to run any of your SQL statements. Either DML or like DDL or DQL, data query language, every SQL statement, even when loading the data, there is a command called copy into. Even copy into also requires a virtual warehouse, and that will be going to use some resources. Those resources will be provided by virtual warehouses to this particular SQL statements. So we need to have a virtual warehouse running to run these SQL statements. So every Snowflake environment will be divided into the 3 layers: the cloud services layer, the first one, and query processing layer, and the third one, storage layer. So this cloud services layer is responsible for the authentication and metadata management, and then security and infrastructure management. All will be like query optimization, all will be done through this cloud services layer only, the topmost layer. Once you log in inside through this layer, you will be in this layer, the query processing layer, which is called as. Here your actual SQL queries will be executed and your virtual warehouses will be sitting in this layer to provide you resources to run your queries. And if you see here, every virtual warehouse is having some size: X small, medium, X large. So you have a different sizes like X small, small, medium, large, like that. So according to your query complexity, you have to select your warehouse size also. Choosing the right size of the warehouse is also very, very important for the Snowflake administrator.
That how we can identify that?
That
depends
initially you start with X small only.
Okay, yeah.
So because we can't directly go and say bigger size, right? We don't know what is the complexity of the SQL statements you are going to run. And even if you are not going to use one single virtual warehouse for all the teams.
Yeah.
You need
But
to
anyway, everything is auto scalable, right? So we can
auto
go with
scalable
the
only,
flow.
correct? Auto
Yeah.
scalable only, but it doesn't mean that people will use the same size of same SQL statements, right? They may run even complex SQL queries also. So when you are allocating these virtual warehouses, you need to first analyze what the complexity, and that can be done in one day. You need to do some trial and error also. You need to identify for each particular team what is the size required. Maybe for a particular dashboard team, I may need to provide a medium size. For a data engineering team, I may need to give some bigger size, like X large. For a looker team who will review the data, I will give only small size. So according to their activities, you have to decide. Because we will come to know, right, after some time, what is the queries they are going to run and how busy the warehouse is. And that calculation, once you perform, you will come to know what is the size required. We can instantly also change required. On file also you can reduce the size and increase the size. Snowflake will allow you. And also Snowflake will come up with auto resume and auto suspend, 2 different properties for every warehouse. As as a Snowflake administrator, while creating the virtual warehouse, we should configure these two properties also. So auto suspend is the property. It will allow us to configure how much time after idleness the virtual warehouse to be automatically stopped. That will, we can configure like 5 minutes or 10 minutes or 15 minutes according to our requirement.
Your voice is breaking.
No, I'm saying that a virtual warehouse can be auto suspended by Snowflake by configuring that property. So we need to configure the property to auto suspend like 5 minutes or 10 minutes or 15 minutes according to our requirement. Why? Because there might be scenarios where your warehouse will be idle also, right? No queries are running. When no queries are running, I do not need any queries to be consumed. Correct?
Yeah.
So in that scenario, we have a property called auto suspend. So Snowflake will automatically suspend the warehouse as soon as it is idle for those 20 minutes. For example, I configure 10 minutes. So after 10 minutes of idle, there is no queries are running, the virtual warehouse status will be automatically suspended. So Snowflake will automatically suspend that. We do not need to do anything. So that will save your credits also.
Yeah.
So initially suspended true, there's a property. So whenever you create a warehouse, if you don't configure initially suspend equal to true, your warehouse will be automatically started, which is not required at all. So as a DBA, we should know I should start with initially suspended true also, right? Correct or not? Others, unnecessarily, we need to keep my warehouse running, even no queries are running.
Yeah.
So all these we should keep in mind. And also start with always X small size and number of clusters also. Every warehouse will be with minimum and maximum number of clusters. And we need to see how many number of clusters is required, because the number of clusters increases, the concurrent execution also will increase. So when you want to increase the number of queries, number of users are more, you need to increase the number of clusters. That is called scale out in Snowflake terminology. Whenever there is a query which is running so much amount of time, long running query, which requires additional resources, then I need to increase the size of the warehouse. That is called scale up. So scale up and scale out is very important. So as a DBA, we need to keep in mind so many things here. You might have done already in the other projects with your existing database DB activities, but Snowflake is also need some part of other activities, which includes like secure data sharing, dynamic data masking, time travel and fail safe, database failover and failback and replication, network policies, and multi-cloud like data transfer. So and pricing management, which is very important, and virtual warehouse management, compute management. So there are so many activities every DBA will work on in Snowflake project as per the regular activities. And how can you go and start using this interface? So we have a Snowset interface. When you create your Snowflake account, when you log in with your username and password, you will enter into a Snowset interface. In the Snowset interface, you can manage most of the things with plug and play. If all you want to run any commands, you can even manage with SQL queries also. There are options. But some of the activities, you can only manage the SQL queries. Like initially suspended true, I can use that property with SQL only. I cannot use that particular property while with the interface. I can also create a virtual warehouse through interface with the plug and play, or I can even create with SQL command also. But some of the properties I can set up through SQL statements only. So I should use SQL queries or SQL statements to perform those activities as well. And Snowflake come up with a command line interface also called SnowSQL CLI. So sometimes you may need to use this interface to load the data as a one-time data loading, like full loading. So Snowflake interface allow you to load data only up to size up to 200 MB. If it is more than that, I cannot use Snowsite interface to load the data. Then I need to depend upon the SnowSQL command interface. Or you may also need to use programmatically, you need to use like Python connector or Snowpark connector also can help us, but you should know the programming as well. And coming to like the object hierarchy, if you see, right, as a DBA or developer, we need to know like how the Snowflake environment will be divided. Is it starts with a Snowflake organization, and then we will have a multiple Snowflake accounts under that. So you will have a organization admin who will manage multiple Snowflake accounts. If you have one account, you do not need organization admin. You can directly go with a account admin, and the account admin is the super user who will take care of the entire Snowflake environment. So at account admin or account is the top level object. Under account, you will have multiple databases. And each database, as you know, it is a group of schemas. And every schema again is a logical group of objects. And the objects in Snowflake are so many objects are there, like tables, views. Additionally, we have like stages, pipes, procedures, streams, tasks. So many different objects are there. All will fall under a schema. So this hierarchy is which you need to see. Say account and then databases. In every database, you have multiple schemas, and each schema again will have like tables, views, and other database objects. And this is what the other objects which I was talking about. Look like warehouses, databases, roles, and users will be under account. And under database, you will see schemas, and every schema you will see multiple database objects, whatever you see here. And coming to like stages. So Snowflake come up with a concept called stages for storing the intermediate data. For all, I want to migrate the data from MySQL to Snowflake. I cannot directly migrate from MySQL to Snowflake. I need to have an intermediate storage. That intermediate storage can be called, it will be called as stage in Snowflake terminology, and this stage can be either it can be internal to Snowflake environment called internal stage, or it can be external to Snowflake called external stage. An external stage will be connected to other cloud storage like S3 bucket or blob storage or GCP storage. If you feel that you don't have any cloud storage, you will depend on Snowflake internal stage. And then you load into the table. If you have any cloud storage access, you will try to use that cloud storage and load the data from that particular S3 bucket, for example, into Snowflake. But for that, you need to establish a communication or connection or integration between the S3 bucket location where your files are sitting and Snowflake environment. And that is some particular procedure you need to follow to create that integration. So this particular activity also a DBA has to take care, because integration will be created only once, and the integration will be utilized by multiple other developers. And stage also we will create only once, and that will be utilized by multiple people. So as a DBA, I need to know how to create a integration and then a stage, and every stage will have a file format. It can be CSV or JSON. Snowflake supports 6 file formats: CSV, JSON, XML, Avro, ORC, and Parquet. You should create a file format object also, because I need to inform Snowflake that this is the type of data I'm loading in the stage. And from the stage, I will clearly load into the table. So this is very important. And apart from that, we also need to understand about the incremental loading. For example, incremental loading, where we go and deal with using a feature called streams and tasks. And network security and network policies, how to whitelist and blacklist the IP addresses, and how to create a private link. All these are part of your DBA activity, the security perspective. And data security also. Snowflake, by default, data is encrypted, and you also can use the Snowflake manager keys and customer manager keys also to ensure your data security here. And you should know how to create these network policies and all this stuff as well. And apart from this, you also need to understand about the multi-factor authentication, how to configure, and keyword authentication, SSO integration with Okta, which is basically very popular in the market. A standard username and password also you can connect, but most of the enterprise companies will go with SSO integration like Okta. And some people also go with like Azure AD and ADFS integration also. And multi-factor authentication is also very, very important. We can even configure that for every user. We can enforce the multi-factor authentication also for every user. And apart from that, the RBAC, role-based access control. So how to create different roles, custom roles. Snowflake provides system roles. Like Snowflake come up with 6 system roles, like organization admin, account admin, security admin, sysadmin, user admin, and public. But all these 6 system roles will be used to manage the entire environment. But sometimes these roles are very powerful, so we are not going to assign these roles to every user. So majority Snowflake projects will have custom roles, like data scientist role, or data engineer role, or a data analyst, or marketing analyst, finance analyst, data steward. So these kind of custom roles will be created and will be granted to the user. They'll assign the roles to the user and they will grant the privileges to the roles automatically. But in the normal traditional databases, I hope you might have already seen how to create the roles and how to grant them or assign them to the users. A privilege, this will be assigned to the role and the role will be granted to the particular user. But here in Snowflake, we have role-based access control. The role-based access control is one of the very important feature which every Snowflake DBA should know, because to create an environment and control environment, you should have the RBAC ready as an initial step. For every project, when I start with the role-based access control to identify what are the system roles and whom to assign and what are the custom roles and whom to assign. And I also added an additional layer to get approval hierarchy also. Snowflake provided roles I can use. But at the same time, to give additional security and authentication, I added an additional level of hierarchy so that whoever want to get access, they should come up with an approval from their manager. So this kind of process also you should create. If you go to majorly banks, they will have this kind of process. And coming to the roles, account admin is the top level role who will have the full control over the environment, and security admin is the person who will have the privilege to create users and roles and grant the privileges. And sysadmin is the role which will help to create the databases, schemas, warehouses, all this stuff. And public is the default role which will be granted to every user by default. And apart from this, a user admin is the child role of security admin. He can support in creating users and roles in the environment by supporting security admin. He can't grant the privileges. And org admin will come into picture only if you have multiple Snowflake accounts. And account level billing and configuration will be done through account admin. That is sufficient. Only if you have multiple Snowflake accounts, then only the org admin will come into picture. And this is the hierarchy where account admin will be on the top, and security admin, sysadmin, user admin, and then public. All these will be under the same level. So a person with security admin cannot do what a sysadmin can do. A sysadmin cannot do what a security admin can do. But account admin can do what these two people can do, because he is the parent. What account admin can do, he will have a full control. He can manage users and roles. He can manage the billing and credit monitoring. He can do the global security and resource monitors he can create. But this particular person with the security admin can only perform the access control. He can't do anything else. Sysadmin can only do the object management, like managing warehouses, managing databases, and then creating, managing schemas, and monitoring queries. Only he can do only these activities. He can't do whatever this particular security can do. And user admin also is a child role of this particular role. He can only create users roles, only those two activities. He cannot do any other activities like granting the privileges, all this stuff. All these we should understand. The hierarchy we should understand. And RBAC is very, very important for admin. Role-based access control and user-based access control, which is now recently added in Snowflake. And warehouse management. So XML size 2 nodes, small 1 node, XML 1 node, small 2 nodes, medium 4 nodes. So you can see when the size increased, number of nodes getting increased and number of credits also getting increased per hour. So XML will charge only 1 credit, large is charging 8 credits per hour and medium 4 credits per hour. You can see the number of credits increased, your charges will increase. So the performance also increase, but you should be ready for paying the cost also. So scaling up and scale out, which I discussed already, how to increase the number of clusters is called scale out. So that will increase the concurrent execution, high concurrency will be there. Scaling up, increase in the size. So complex queries, large data loads, which will basically Snowflake will experience data spilling, which is an issue when you are running any query which is unable to fit the data queries in the memory, that will be moved to the local disk and then to remote disk. In that scenario, your data retrieval will be very slow. In that particular case, you need to increase the warehouse size so that you will get additional resources. So it will increase the query speed. Scale up will increase query speed, whereas scale out will improve the concurrent execution. I hope everybody is following. Any questions?
Yes, sir. We are following.
Okay, so this is basically, see, all these as a DBA, you should have some clarity and when to scale up and when to scale out. When I need to configure auto suspend, and auto resume is another property you need to enable so that whenever your warehouse is suspended, I want my warehouse to be automatically started whenever my query will start executing. Though auto resume you should enable like this. See, with the command I can create a warehouse, a medium size warehouse, auto suspend 60 seconds, like 1 minute, and auto resume true. These two properties are very important. So 1 minute auto suspend, after 1 minute of idleness, my warehouse will be suspended automatically, and whenever my query will start executing, automatically my warehouse also will be started. This is auto resume true will do. And there are some scaling policies also, but I want to discuss them later indeed. And resource monitors are very important for DBS because these resource monitors will try to control the warehouse consumption. I should have a separate resource monitor for every warehouse because the billing spikes, it will control. You will have a credit quota which you can configure after 50%, what to do. After 60% of credit consumption,